Hello, everyone. Welcome to PulumiUP session. Today, we'll talk about security of infrastructure as code pipelines and infrastructure governance with policies as code. I'm Marina Novikova, and I am Senior Partner Solution Architect at AWS. And I joined today by my dear colleague, Andy Teller, who will introduce himself a little later. So let's get started. We all part of different teams. In different organizations, it might be split in different way. Some team are DevOps, some team of the platform engineering, or infrastructure actual responsibility of developers. But we all have in common, and typically a lot of things to think about. First of all, running at scale, significant amount of infrastructure, VPCs, multiple accounts, multiple regions, multiple databases, multiple compute instances. We need to meet the infrastructure need of multiple teams, and it can be vary from serverless to Kubernetes workloads, or even can be hybrid workload when it's partially on data premise. We need to able to automatically deploy any infrastructure changes 24/7, the same as application code, to serve our customer the best and the newest one with most recent functionality and to meet the business needs. And we also wanted to experiment at scale and do new things and do it different ways. And we wanted to make sure it's all standardized and consistent with our approach and compliance. And of course, things go wrong. They do go wrong. We need to think about disaster recovery or a new security risk or infrastructure we detected to make sure we can easily to make this change and deploy at scale. Is it familiar to you? It's familiar to me. So let's think and see how we can solve it. Let's talk about security as a code. What is it? Security code is approach when we implement security the same way as infrastructure code. It has a lot in common, and of course, it has a lot of common benefits to that. First of all, governance. We can support business objectives by defining policies as small rules, depends on our organization needs, and to control and manage risk and align with our best practices and business objectives and make sure infrastructure is effective for organization. It help us to meet compliance needs. We work in different industries, in different countries and regions. Compliance needs vary. It also evolve and update. For example, recently Europe introduced a new compliance regulation for resilience, DORA metrics. And we wanted to make sure it has been applied to all our infrastructure at scale, and all new infrastructure created follow the same rules. Cost optimization. It's probably as a developer, so DevOps, we don't think about it every day, but our organization wanted to make sure that it's controlled. So how to enforce specific policy for specific environments, for specific teams, for example, that in development environments, you can provision only that set of the small instances, but for production, actually, we need a real workload instance, right? Fine-grained control is achievable with security as code because we can create this small definition of policies, make sure we combine and pack them in different way, depends on our team, depend on our needs. And we want to make sure that it's the same environment to environment. There is a consistency, there is repeatability. We can easily to enroll it for a new region in the same manner as exist. But also talking about consistency, think about other stuff like we wanted to make sure we enforce tagging and naming rules for our infrastructure so we can easily like group infrastructure and like understand like cost of different application and services together or for other reasons. Another big advantage of security code, it's preventive. Let's think about it. There is a preventive controls, which means we prevent some risk and security issues to go and be deployed to our infrastructure, to our environment. And there is detective one, and detective, you might be familiar with some services like AWS Security Hub and AWS Config. They both need it. We don't say one another. We want a both. But there's significant difference if we start implementing the security early in the cycle, that it helps us to mitigate most of the risk before it even deployed infrastructure. On the face of the requirements, we understand our compliance and our organization needs. On the stage of development, we can implement this policy and group these policies into pack who need to be applied to our infrastructure. It can be tested, right? Yes, because it's a code. And it actually can be deployed and enforce it during deployment in our CI/CD pipeline. AWS. Security is our top priority in AWS. And I hope you're familiar with our shared responsibility model. AWS is responsible for security of the cloud. Yes, we control security of hardware, global infrastructure, access to data centers, and all inside of our data center, what we can control. But there's still a lot of responsibility which own customers, right? There is encryption rules, there is a customer data classification and a data protection. For example, we don't want our S3 bucket to be public, everybody able to download our audit report, right? So the line actual of responsibility vary depends on the type of the services. For example, when we're talking about infrastructure services, they're more customizable, but there is a more customer responsibility to manage all different type of the security areas. But when we're talking about managed services, it's less customizable, it's less customer responsibility, more best practices already built in, but there is still some set of the rules we need to enforce. For example, encryption. All of this is on us, and there's a lot of it. Let's talk about compliance. AWS compliant progress includes multiple regions and standards. Yes, we're responsible for security in the cloud, but security in the cloud still on you. You still need to go step by step of the rules and make sure all of this compliance and standards you need to enforce actually met for your infrastructure you deploy. Who has access to which type of the databases? Like if encryption in transit and at rest is on. So let's talk about translation to policies. If you look on our set of the customer responsibilities, can we ask right question which actually address our organization need, address our compliance need, and map to this responsibility? Yes, we can. Can we write the security security policy for this? Yes, we can. MFA zone. Encryption at rest. Is EFS encrypted? RDS is encrypted? Is EKS API publicly accessible? Is S3 bucket public? Or security group allows inbound traffic? You can get familiar with a very specific security rules we actually recommend to enforce for data protection and customer responsibilities on our documentation, and I really highly encourage you to do that. But you also can implement that with a Pulumi policies. You can create customized policies, you can pack them the way how actually it meets your team requirement, organization requirements. Let's talk about a little more about Pulumi compliance ready policies. That's a set of the compliance prepared, the compliance framework prepared policies which are already listed in the Pulumi, and you can go and pack them, depends on your requirements. For example, if we are talking about PCI DSS compliance requirements, and we know that we work with specific server like EC2 or S3, this example actually demonstrated as how we can just list and enforce specific policies to our in our organization level to our deployment. I highly recommend you to get familiar with that, but more is coming in the second part of our presentation is ending. We talked about security of infrastructure, how we can bring into pipeline. How about security of pipeline? There's a different type of sensitive information we need to manage during deployment. There is deployment options, API keys, database credential, tokens. And teams, like, they store this credential in different locations. It's really hard sometimes to enforce teams to use the same tools all at the place, especially in a big organization. There are multiple environments, depends on your culture and process. There might be development, staging, production, but it actually might be much more than that. So Pulumi ESC allows you to control it all in one place. Environment contains collection of secrets and configurations. So create environment by environment. We don't want the same tokens and configure it for each of them. There's a variety of configuration secrets storage integrated with Pulumi ESC. For example, AWS Secrets Manager. There is a rich API for automation for platform engineering team, how we can work with environments. And of course, it's first you want to audit it, and it has role-based access control built in, which is extremely important because we don't want to give access to our secrets configuration to everyone. Well, hope it was helpful. I know the security is important. We don't sometimes want to care about this, but we have to. But let's see how it works in practice with Anti-Teller.
Marina, thank you ever so much. In this upcoming demo, we're going to go through Pulumi policy as code, or otherwise known as Pulumi CrossGuard. Throughout this short demo, I may often use those terms interchangeably, so I hope that's okay. As you can see in this diagram, we have quite a common architecture, which is a AWS hub and spoke architecture. This consists of an AWS transit gateway, which provides the core routing capability, workload spokes, which are in the diagram on the left-hand side above the transit gateway, and a centralized inspection VPC on the right-hand side of the diagram, which consists of having an AWS network firewall with a firewall policy applied to that to provide security enforcement. I've also provided a different view of the architecture on the right-hand side of this slide, which gives a little bit more detail around the route tables to make the routing work in this architecture. On the bottom of the slide, on the right-hand side, there's a link to a blog and a GitHub repo that walks through how to build this architecture yourself using Pulumi if you wish to do so. So from here, we are going to look at common separation of duties between the network team and the security team. So as you can see from the output from PulumiUP, we've got over 90 resources created by this relatively straightforward architecture. The network team's responsibilities is really to ensure that the routing is working, which comprises of AWS Transit Gateway, provisioning standardized VPCs for workloads, a centralized inspection VPC, which hosts an AWS network firewall with an endpoint in each availability zone, and that will typically come with a base policy. And then we also need to make sure that prior to being used, all of the routing works, so we know that end-to-end connectivity will work, and then we'll get centralized inspection done by the AWS network firewall. The security team, on the other hand, have got to have responsibility for the AWS network firewall security policy that's applied, and make sure that policy complies with any governance, audit, compliance, or I should say the wider organizational security policy, which can be subject to change as the threat landscape evolves. So that presents a number of challenges. We typically see quite a high rate of change within the network firewall security policy, which needs to be highly automated to meet SLAs for the DevOps teams that are building applications and services. We want to try and minimize human review. It's error prone and it's hugely resource intensive. So we want to try and do this through code, which we'll demonstrate is a much better way to do things. This is typically done through pre-deployment stage in a CI/CD pipeline. We won't be using a CI/CD pipeline in today's demo, just to simplify and really focus on CrossGuard rather than a CI/CD build out. We also need to make sure that the policy as code, or the policy pack, which we'll get into in a little bit later, evaluates not just the proposed changes for the change in question, but any existing rules that have been there for some time, if the organizational security policy changes, we've got to make sure that the existing policy within the AWS network firewall still adheres to that wider organizational security policy. So what is Pulumi Policy as Code? As I said before, it's better known as CrossGuard. We'll be using policy as code to translate just a very small part of normally a wider security policy to code. In this instance, it'll be stopping any egress traffic or outbound traffic to the internet using HTTP. I mean, we really could be using HTTPS only, because HTTP, as you know, it's not encrypted, and therefore this particular organization doesn't want this traffic egressing from its organization to the internet. What's the policy? So in summary, a policy contains specific logic that you want to be enforced. Again, in this instance, that logic will be no outbound or egress HTTP traffic, which, as you know, is TCP port 80, to any destination and from any source. So when we apply this to AWS network firewall policy, we need to apply it in several places to make sure that this is caught on all possible policy types. Now, those policy types are stateless policies, stateful policies, and then stateful policies with Suricata compatible rules. And if you want to look more at the Suricata rules, we've got a lot of information on that on the AWS website. Suricata rules are often slightly more complex, but provide a lot more capability with deeper deep packet inspection. So in this particular slide, you can see an example of a stateless rule, which in this case is allowing HTTP on TCP port 80. I won't keep saying that. You'll then see an example of a stateful rule, and the same thing then, a stateful rule in Suricata format. And I guess that's fine if we've got one policy that contains just these three rules. But when we've got hundreds or thousands more rules on there, how do we evaluate this at scale? So as we said before, doing this with human review is error prone. It's hugely resource intensive and quite difficult to do. So what does our policy look like? As part of this demonstration, we'll be providing a link to a repo with all of the code in it, so you can go through it in more detail. But at a very high level, we're providing, in this case written in Python, a function here that will go through each of those policy types. As you can see here, we've cut it down into a stateless rule validation. We then check for a stateful rule validation, and we check for the semantics within the Suricata stateful rules, and checking for a source, a destination of any, i.e. out to the internet, the protocol being TCP, the port being port 80 for HTTP, and the action as allow, or in different parlance, pass, or accept. So we're basically saying any traffic that's leaving our network destined for the internet using TCP port 80, i.e. HTTPS, must be dropped. What we can see here is when we apply a policy pack, we'll run a PulumiUP, and as you can see from just a screen capture, but we will show a screen recording shortly. Now, what has changed here is the firewall policy's changed. So what I've done is I've added some additional rules to the base policy, which I know will fail this validation. And these really are under stateless, stateful, and Suricata rules, basically allowing HTTP out to the internet. And as you can see here, when we run the PulumiUP with a policy pack specifically to catch or to look for unrestricted HTTP traffic out to the internet, you can see that Pulumi CrossGuard catches that and raises an error. Now, typically what would happen is, as part of a CI/CD pipeline, once the user has submitted an intended firewall change, there'll be a dedicated stage within that CI/CD pipeline that will validate the change. It'll validate it syntactically, semantically, and then it'll look for the policy pack applied to the AWS network file policy to make sure it's compliant. Otherwise, it will raise an error and it'll be rejected. But this is a very timely rejection, so the user, once it's submitted this, will get information back very quickly to inform him or her that the policy doesn't meet the wider security policy and therefore will be rejected. What are policy packs? So a policy pack is a collection of policies that will enforce one or several policies, normally grouped in kind of related policies together. One of the things that's really, really important, I think I've mentioned it a couple of times, is that when we evaluate the policy pack against the policy that's being pushed through or submitted, as that policy will contain not just the additional security policy that the user wants to put through to get additional access, but all of the, given this is used infrastructure as code, the code base itself will include all of the existing rules as well. Now, the good thing about this means that every time a change goes through, it's validating that not just the differential is compliant, but the policy as a whole. So that means that if you have a change in the wider organizational security policy, then as long as that's coded into CrossGuard, that will always make sure that your policy that's on your firewalls is compliant. Demos. We all have a demo. Let's see if we, this is a recording, so I have less reliant on the demo gods, but I will now play this and I'll walk through as we do this. So what I've got here in my repo, and you can see the files that are in there. It's a very basic repo which you can get and do yourself. Now, if we look at the firewall rules that are in this repo, we can see that this is a very base policy. There's not a lot in there, and therefore we know that that's going to be compliant. We've also got a policy which we will apply to the base policy, and then we'll reapply to an amended policy, which I've called invalid, because ultimately it does try to get out to the internet with unrestricted HTTP access, and therefore the Pulumi CrossGuard should catch that. So we've done a PulumiUP here, and you can see once this comes back that there's nothing changed. The base infrastructure has been deployed and there's nothing that's been changed from that. So what we're going to do now is we're going to run a PulumiUP with the policy pack against that base infrastructure, looking at the AWS network firewall policy. And then as that goes through, you can see that it's a compliant. What you'll see next to the policy is a nice little green box with a tick saying it's all good. There we go. So it's gone through that and it's shown that it's a good policy. It's fine. So I'm going to switch over now to another branch within the Git repo with contains an invalid policy. Once again, we're just going to look at the policy quickly. Now, as we go through the policy, you can see I've added some additional rules in that proposed policy, which CrossGuard should catch because it's asking for outbound traffic to the internet using port 80. And again, just going through the policy again really quickly, just to show you nothing's changed. So we run a PulumiUP. Now, as we know, the only thing that's changed here is the policy. So what I'm expecting now is for Pulumi just to show me the policy's changed and I've added some additional rules into the firewall. Excellent. So that's essentially what you see. So now what I'm going to do is go through the detail of that just very, very quickly. And as I scroll up, you can see here the proposed change, which includes this additional changes that I've put in as part of the new policy, AWS Network Security Policy. So now if I run the Pulumi policy pack against the updated or invalid policy, that should now go through checking the infrastructure, but it'll also check the AWS network firewall policy. You can see again, as before, it's picked up the fact that some additional rules have been added and that the base policy has been changed. And now you can see from here that CrossGuard has actually dropped that or raised an error that this is an invalid policy, and the submission will be essentially sent back to the requested user with information to explain why this particular policy or change has been rejected.
Thank you, AJ. It was amazing. Thank you for all information and demo you did. I hope, guys, it was extremely helpful to you. I wanted to leave you with a couple of links to check. It's a AWS Shared Responsibility Model. It has a link to all of these security practices service by service I talked about. I highly go get familiar, start implementing. Go check and play with Pulumi compliance ready policies. Depends on the compliance standards you have to implement at the organization. Check Pulumi ESC. I hope it's going to be all helpful for you. You can connect with us via LinkedIn. It's below our LSC there, how to find us. And the last one for you, if you want to actually do a hands-on practice with us, join me and Pulumi solution architect Josh on our workshop on September 26th. That's the QR code for this one. See you there. Thank you. Have a good
Thank
rest of the day.
you so much for all the hard work you've put into this, and I really hope people found benefit. I look forward to syncing with you all. If you've got any questions, please reach out, and I hope you enjoyed it as much as we did.